In this lesson, we'll look at the design considerations you'll want to make when working with the IQ8 commercial microinverters. After this lesson, you should be able to apply correct module pairing, know when to use line filters on your projects, and apply system sizing considerations. Enphase commercial microinverters are compatible with most modules you'd want to use. They are compatible with modules with an output rating of between 320 and 640 watts depending on the model you select. You can use modules with almost any module cell configuration on the market that you'd want to use on a commercial project. The maximum DC input voltage is 63 volts for both models. The PPT voltage is between 28.5 and 53 volts depending on the model you choose. The operating range is between 16 to 63 volts for both models, and the min-max start voltage window is between 22 to 65 volts for both models. Because IQ8 commercial microinverters use reactive power, its output power is measured in volt-amps instead of watts, but you could think of them in a very similar way. The max output power is 384 for 8H and 480 for 8P. The max continuous output power is 380 and 475 respectively. The nominal voltage range is 208 with a max output current of 1.83 for H and 2.28 for P. The maximum number of microinverters per branch circuit is 15 for 8H and 12 for 8P. IQ8 commercial systems can be used at most sites in North America. Natively, they support 208 VAC 3-phase Y sites. With transformers, you can support other 3-phase voltages. If your site has a different configuration, like 3-phase delta, a standard delta to Y transformer can be used. Single-phase service is not supported. Because these systems use a 4-wire configuration, you will need a neutral wire at the microinverters where the gateway is installed. The three components that will influence your system design the most are the IQ8 commercial microinverters, the QD cable, and the gateway, which can communicate to up to 275 microinverters. Let's talk about the interplay between these three components and how that affects design. The commercial gateway uses power line communications to communicate with microinverters. It's capable of communicating with up to 275 microinverters at a time over the power lines. Power line communications is limited to 240 feet. The commercial gateway can use either Ethernet, Wi-Fi, or cellular to communicate with the cloud. So since the branch circuit size is limited to 15 per branch with 8H and 12 per branch with 8P by the number 12 conductors in the QD cable, and a commercial gateway is able to communicate with up to 275 microinverters, the maximum amount of fully loaded branch circuits we can have per gateway is 23 for 8P and 18 for 8H. That's the equivalent of about 132 kilowatts per gateway for 8P and 105 kilowatts for 8H. If you're planning on building a system greater than that, no problem. Just add more gateways in increments. Powerline communications with the microinverters is at 110 kHz and directly through the AC circuits. If you're building a larger site with multiple gateways, you'll need to add line filters to prevent interference or crosstalk over the separate domains. For clarity, if your site has only one gateway, a line filter isn't needed. If you had 5 gateways, you'd need 4 line filters in order to keep the PLC communications separate. Here's a basic diagram of a site with multiple gateways. It's a 396 kilowatt system with 825 8P micros and 3 commercial gateways. Notice that there are line filters dedicated to each commercial gateway after the first, so that the modules associated with each gateway don't interfere with each other. You can just scale up as your system size increases.